All right, let's do some Mathity-Math. It says here, multiply and simplify the radical expressions. Okay, so we have a binomial multiplied by a binomial, and that's okay. We can handle this. When this happens, we typically just FOIL. We do the front ones or the first ones, and then we multiply the outsides, then the insides, and then the last, right? That concept of FOILing is actually the same as just saying, I'm going to take this term and multiply it here, and then I'm going to take this term and multiply it there, then I'm going to take this term and go here, and then this term and go there, right? No matter how you like to think of it, we will follow that same process. So here we go. The square root of 3 multiplied by the negative square root of 3, well, that negative would come, and then we just multiply. Root 3 times the root 3 gives us root 9. Okay, so far so good. Okay, that was the first stage, front. Then we can do the outsides, okay? Root 3 times negative root 2 is going to give us negative root 6, okay? And these are multiplying. Oh, excuse me, there's a subtraction sign there, excuse me. So it's negative root 9 minus root 6, excuse me. Okay, so then we do the inside. Negative root 2 times negative root 3, well, a negative times a negative makes a positive, and root 2 times root 3 is root 6, okay? And then we do the last ones. Negative root 2 times a negative root 2. Well, a negative negative makes a positive, okay? And let's see here. Root 2 times root 2 is root 4. Okay, so at this point now we can see if we have any perfect squares, which we do. The square root of 9 is 3, so this would become a negative 3. And let's do a little side bubble here. I do like to kind of explore why this happens. I think it's a worthwhile endeavor. You see, root 9 can be thought as being broken down to root 3 times root 3, okay? And root 3 times root 3 is the same as saying I have root 3 squared. And a square root and a square cancel, so those will go away, and you'd only be left with 3, and that's why we get left with just a 3, okay? So now you have minus root 6 plus root 6. Well, those are opposites, right? If you have a minus root 6 and a plus root 6, when you add those together, you get 0. So these actually go away. Goodbye. And then the final thing here we have is plus root 4. Well, the square root of 4 is 2, so that's plus 2. And you can follow that same logic here if you want to do one last little side venture. I'll actually break this one down a little differently, right? You could say root 4 is the same as root 2 times 2 and leave it inside like this. And then say, well, okay, 2 times 2 is 2 squared, so that's a root 2 squared. And still, regardless, you have a square and a square root together, and those will cancel, and you'll get left with just 2. That's why that works. Okay, and then we say, well, what is negative 3 plus 2? Negative 3 plus 2 is negative 1. And voila, you're done. You did it. That was a very good job. We took all of this, we multiplied it, and simplified it all the way down into a lovely, simple, elegant little negative 1. Good job. As always, if you want to be notified when more math problems are coming your way, go ahead and subscribe. And if you have any questions or comments or need clarifications, just leave a comment below, and I'll do my very, very best to answer all your questions. Thank you. Bye.